about how agentic AI creates new demands and what we expect those demands to be. And we're also going to talk about how telcos can potentially find some success and some growth from opportunities that agentic AI systems throw up, both in terms of the dynamic coordination of compute connectivity and the coordination and orchestration of data as well. It's a great topic. We're going to be joined by some panelists from Orange, from Vodafone, and from Red Hat. But before we do, we're going to have a presentation from my colleague Jack. Just to give you a few bits of housekeeping that you may have heard before we jump into that though, you are in listen-only mode. If you're having issues with audio, feel free to leave a comment in the questions tab, and one of our team members will try and help out. We are going to have some presentations to start off the session today. Those will last just under around 30 minutes, and then the second half of the session will be panel discussion and Q&A. So do feel free to submit questions that come to your mind throughout either of the presentations using the questions tab that you should have up in the interface. And you can also submit questions during the panel discussion as well, which we'll try and get to live. One very common question that we get asked is about, will you receive the slides or a recording of the session? So I can tell you up front that yes, we will be sharing that with everybody that registered. You are welcome to share those slides and the recording on with any colleagues who've missed it, who you think might be interested. And just before I hand over to Jack for the meat of the presentation, a few words on STL if you don't know us so well. We are an advisory company. We have two arms, a sort of market and research arm and a consulting arm where we provide bespoke advice, and we really work across the telecoms, technology and digital infrastructure sectors. So that's kind of the overview of who we are and the session today. I'm now going to hand over to my colleague Jack, who is going to lead you through an STL presentation to kick things off. And then he will also hand over to Red Hat and then chair through the panel discussion, where we'll be welcoming Miguel from Orange and Andy from Vodafone. Over to you, Jack.
Perfect. Thank you very much, Tilly. So today, most AI systems we use are standalone models. If you think of ChatGPT, which many of us rely on to boost productivity from time to time, they may or may not have helped me compile this deck. You type a prompt, it processes the request on a central server, and then gives you back a response. It's effective, but the interaction is one-dimensional. The user's got to guide the model closely, check the output, and repeat the process if it's not quite right. For example, imagine you're visiting a new city and want to know what's happening that weekend. ChatGPT can give you a list of events summarizing what's on and where, but that's sort of where it stops. An agentic AI, on the other hand, could go much further than this. It could check your calendar, see when you're free, book tickets, and even arrange travel and reminders, all without you needing to ask for each step individually. It doesn't just tell you what's possible, it takes action to make this happen. And that's the fundamental shift that we're seeing with agentic AI systems. Instead of this single model waiting for prompts, these are networks of specialized agents, each handling a subtask while coordinating together toward a shared objective. And the crucial difference is really around this reaction rather than just acting like ChatGPT does. It takes initiative, it can call external tools and systems, it can collaborate across agents, and it works proactively to achieve the goal rather than waiting passively for the next user interaction. It makes the interaction much more collaborative, less dependent on constant oversight, and far closer to how we'd work with a human teammate. And we're already seeing this shift play out from mission critical sectors like healthcare to everyday consumer tasks like the one I mentioned around scheduling or booking travel. Over the past 18 months, both investment and general discussion discourse around agentic AI have surged. And if industry forecasts are to be believed, that momentum will only accelerate. And here we've used Market Us's forecast for the global agentic AI market from 2024 to 2034. They project the market reaching almost 200 billion USD by the end of the period, and that's driven by a compound annual growth rate of 44%. Importantly, most of that growth is expected to occur after 2030. but the groundwork for capturing value is being laid today already. Earlier this year, NVIDIA launched its agentic AI blueprints, allowing enterprises to quickly deploy agents that reason, plan, and act autonomously, with their CEO, Jensen Huang, even suggesting that enterprise workforces will soon be joined by millions of AI agents. In June, Accenture, they unveiled its AI refinery distiller framework and software development kit, positioning itself as a platform provider for enterprises to build, to deploy, and scale agentic systems. And they're far from alone. You've got Google, Microsoft, OpenAI, IBM, and Meta, all rapidly advancing their own agentic AI capabilities. And together, these forecasts and announcements show that agentic AI is not just a buzzword, it's fast becoming a strategic priority across the technology industry. When we look at these big technology players leading in agentic AI, it can be a little bit difficult to envisage where telecom operators are actually going to fit into this. But one of the clearest opportunities that we see is in orchestration, which is essential when agentic AI runs across more distributed and global systems. And again, we'll come back to this example and the key differences between a model like ChatGPT, which is a general purpose model sitting in a central data center. It will take a guess at pretty much anything you ask of it, makes it very powerful, but also very broad and computationally heavy, not always the most efficient. Whereas agentic AI, instead of one model trying to do everything, you orchestrate networks of specialized agents, each designed for a narrow set of tasks. And this means an agent doesn't waste resources guessing outside of its expertise. It's optimized for a specific job. And from a compute perspective, we see this as being far more efficient. And as well, from an outcomes perspective, it delivers higher quality results. The challenge and thus the opportunity comes from bringing those many agents together. They don't all sit in one place. Some may run in the public cloud, others at the local edge, and others still on premise within an enterprise facility. Yet they need to collaborate seamlessly to achieve complex goal-driven tasks. And to make that possible, orchestration is required to ensure agents can coordinate across diverse infrastructures, allowing automated workflows, tracking progress, and allocating resources efficiently, and also handling failures if and when they arise. So in short, the scaling of agentic AI depends not just on having bigger models, but on having the right architecture to orchestrate potentially hundreds of specialized agents. And this distributed, efficient approach allows them to work together as a single coherent system. And we'll explore that in use cases in the coming slides. So there are some enterprise environments where orchestration is relatively straightforward. So if we try and picture this example, where we've got a mid-sized biotech company operating a single research facility, all of its computing power is sitting in one on-premise cluster with research data stored locally and no remote site to connect. In this instance, every agent is running within the same physical location, and they are connected by a single unified network. So we can imagine 3 agents that are at play here. The first is a lab operations agent that's handling scheduling, equipment collaboration, and inventory. The second is a data analysis agent, which is processing images and instrument outputs. And the third is a report generation agent, which is compiling results into regulatory compliant formats or internal summaries. And the workflow here is pretty simple. The lab operations agent triggers the data analysis agent when an experiment finishes, and that analysis agent then sends results to the reporting agent, and the reporting agent generates a draft report for review by the user. Because all the agents are sharing the same data lake and the compute resources, orchestration is relatively easy. Latency is not really a problem thanks to the local area network, and security is managed under a single consistent policy framework. But while this contained environment makes orchestration very simple, it is increasingly rare, and most modern enterprises are far more distributed, with operations spanning multiple sites, multiple clouds, and networks. And in those scenarios, the orchestration challenges become far more complex. So let's now move on to a more complex example. If we imagine a global automotive manufacturer headquartered in Europe, it's got plants in Asia and North America, and design teams plus its actual fleet of vehicles spread worldwide. This is a highly distributed environment, and therefore it demands much smarter coordination than the contained biotech scenario we looked at on the previous slide. If we just think about the infrastructure at play here, the company's running dual data centers in Europe and Asia, and workloads are being split across on-premise systems, multiple public clouds, and telco edge clusters deployed near factories. So if we break down the agents, and there's going to be 5 in this scenario, the first is the design collaboration agent, which is hosted in a public cloud. This manages design software versions, simulation updates, and design reviews across global teams. The next is the supply chain agent, which is split between on-premise systems and a public cloud. This tracks inventory, predicts shortages, and adjusts supplier orders as and when needed. The third is the production line optimization agent, which runs at the telco edge. And this is close to the design factories, where it ingests live IoT sensor data and adjusts robotic assembly in real time. Penultimately, we have the vehicle quality assurance agent, which is hosted in the public cloud. This analyzes images, sensor data from end-of-line inspections. And finally, the fleet performance agent, which is also in the public cloud, but is processing telemetry from connected vehicles to spot any early maintenance issues. And we're already starting to see a little bit of how quickly complexity grows when there are lots of different agents that are spanning clouds, edge, and on-premise infrastructure, and why orchestration becomes a bit more essential. So to bring this to life, let's look at how these agents interact across geographies and across infrastructure types. So we'll start with the interaction between the design and supply chain agents. A new component design from the collaboration agent in Europe triggers the supply chain agent. And this runs partly in an on-premise ERP system, the system of sort of recording for compliance and supplier data, but also partly in the cloud, where optimization models simulate sourcing scenarios and costing. Once sourcing is finalized, orders will then flow to the production line optimization agents, which will be running at the edge, physically close to the manufacturing factories in Asia and North America. And the edge location is crucial here because it's allowing these agents to ingest IoT sensor data directly from the assembly line and make split-second adjustments to robotics and workflows. By processing the data locally at the telco edge, they reduce latency, cut bandwidth use, and ensure production keeps running smoothly even if the wider network connection fluctuates. Data from these production sites will then be streamed into quality assurance systems in nearby public clouds. So, as I mentioned, we've got one in Asia and one in North America. It could be that it's an AWS Singapore, based in Singapore, for the Asian factory, and then it could be that it's a Microsoft Azure cloud in the east or west of North America, each with edge pre-processing to ensure low latency. And defect data here will also be flagged back to Europe for compliance oversight. Once cleared, quality assurance data then feeds into the fleet performance agent, which runs across multiple clouds. This agent is monitoring the vehicles in the fleet globally, looking for the emerging issues like recurring component faults. And finally, the fleet insights cycle back to the design agent in Europe, triggering updates that ripple through the entire supply chain, production, quality assurance, and back into the fleet. And this constant back and forth illustrates the real-world complexity of managing distributed agentic systems. Now, if we take a bit of a step back and look at the full picture, we see just how distributed these systems are. The agents are spread across factories, design hubs, public clouds, telco edge clusters, and even inside connected vehicles. And this is global. Each of these different domains and areas has its own latency requirements, its own security constraints, and its own governance rules. And we've been doing recent industry research, and we found that while AI and agentic systems will certainly drive more data movement, the overall increase in network traffic volume may not be dramatic as many first expected. However, what will matter far more is the quality and the reliability of that traffic. And that's because the data flows between agents are highly variable. Sometimes it's just a tiny package, enough to trigger a simple sequence. Other times it's a huge complex file like a CAD drawing or a simulation output. And this variability puts intense pressure, not just on bandwidth, but on latency and delivery assurance. Even a small delay or a single drop packet can ripple through the system, And in these environments, latency spikes don't just allow or slow one task, they can cascade into then system-wide delays, leaving agents stalled, workloads disrupted, and critical decisions postponed. Without the orchestration, the supply chain agent might not receive defect alerts in time, or it could be the production line agent could miss critical updates from the quality assurance agent. And in other words, we're basically saying that agents will end up acting in silos, slowing down decisions and increasing the risk of costly errors. But with intelligent multi-domain orchestration, the system behaves as one coordinated entity. Information is flowing seamlessly between agents across regions and infrastructures, ensuring that design changes, supply chain adjustments, production updates, and fleet monitoring are all working in sync. And this is the reality for most large enterprises today. And it's exactly where we see telecom operators with their reach across networks and edge sites to have a pivotal role to play. So if we just sort of recap the challenges in our automotive example here, we can then start to identify how telcos can uniquely solve them. So to recap, the first challenge is we've got multiple cloud data flows coordinating across AWS, Azure, other public clouds, and edge compute while respecting data residency rules in 3 different jurisdictions. There's also a latency issue where the quality assurance feedback and real-time production tweaks may demand latency of sub 50 milliseconds, and those responses are required across continents. There's also a security and policy alignment here that needs to take place. Each plant, each partner, or each cloud may use different identity access systems, which require consistent and fine-grained policy enforcement. And finally, there's a workload placement issue where some agents may run inference close to data sources like the edge, but other long-term learning or analytics may live in central clouds. So a telecom operator as an orchestrator, how can they help? And the first is around edge orchestration. Telcos can dynamically schedule where agent workloads run, whether it be on local edge nodes, the cloud, or a hybrid. Optimizing for latency, network conditions, or cost without an enterprise having to re-architect everything. The second perk that telcos possess is the secure interconnectivity piece, where operators can manage private, policy-driven data paths between clouds, on-premise, and other edge sites, ensuring that agents can share data while staying compliant with regional regulations. The third is around network ownership and fine-tuning. And because telcos design, own, and operate the infrastructure in many cases, they can optimize routing, bandwidth, and quality of service for AI and agentic traffic, which is something that maybe hyperscalers can't control end to end. The final advantage is around trusted resilience, with telcos being neutral across vendors, which can offer strong SLAs in uptime, security, or performance across the full orchestration stack. With these orchestration capabilities in hand, telcos are not just commodity connectivity providers anymore. They become a foundational layer in the AI stack. And from here, we can see them start to expand their services into lots of different sectors like healthcare, energy, logistics, or anywhere low latency and privacy where they matter. So to sort of conclude, we recommend that there are 3 steps for telcos to seize the agentic AI orchestration opportunity. And the first is around building flexible, open orchestration platforms. And we're fully aware that telcos can't do this alone. Agentic AI is involving diverse models, different agents and environments, but also vendors that no single ecosystem can cover everything. And that's why telcos must sort of champion this open multi-cloud orchestration platform, which is not tied to one hyperscaler, say. The platforms, they need to be scalable, they need to be flexible and ecosystem ready, much like the Red Hat style infrastructure, which Rima will share shortly, that's become sort of industry standards. The second recommendation is around trialing and partnering and start to move beyond the proof of concept. So while, of course, telcos should be trialing agentic AI widely, both internally as enterprises themselves, but also externally with customers and partners, these pilots shouldn't just stop at technical feasibility. They need to actually test the orchestration impacts and uncover network requirements, and most importantly, actually identify which use cases can scale commercially. The differentiator is not running a proof of concept, it's actually moving quickly from the pilot to resourced revenue generating propositions. And the final recommendation is move fast. leverage the telco strengths that we outline and start to act now, because this opportunity is real, it's immediate. Agentic AI is very much here, and it's clearly going to be evolving fast. Telcos have got these unmatched strengths with their infrastructure and orchestration, but also trust capabilities. But the execution environments are shifting and competitors are moving quickly. So enterprises will choose to partner with companies that can coordinate across domains. So the takeaway really is to invest in these orchestration capabilities now before others start to define the telco role within the AI era. Thank you very much. I'll now hand over to Rima.
Hi, everybody. My name is Rima Yantel. I'm a Chief Telco Architect here at Red Hat. And I'm going to reiterate on a lot of the points that Jack already made. Next slide, please. Please remember that telcos have been doing AI for quite a long time. We used to call them rule-based expert systems and use them for fault management, allowing us to diagnose and troubleshoot our networks. And then we saw the emergence of self-organizing networks that added automated planning and configuration. And then more recently, within 5G networks, there are network and management data analytics functions as well. And then, of course, Gen AI came on the scene, and we saw an explosion of all sorts of chatbots, external customer-facing, internal for the operations. And now we are seeing another shift in the AI landscape, and we are moving from predictive analytics-based AI and even creative Gen AI stuff to this goal achieving with agentic AI. And agentic AI comprises distributed multi-agent systems that collaborate across device, edge, and cloud. And in the nature of agentic AI is to fundamentally change what the core challenge was, which was compute, right? To create smarter, more capable models, to now being able to coordinate and manage distributed interactions. And that's really a networking and orchestration problem, which could be a sweet spot for telcos. Next slide, please. There's some fundamental characteristics of agentic AI workloads that differentiate them from our traditional IT and networking workloads. And telcos can address those characteristics with their set of capabilities. As Jack mentioned, agentic AI is goal-driven. They basically autonomously decide the steps, they use the tools and execute actions needed to achieve those goals. Agentic AI workloads are very dynamic and also unpredictable in their resource consumption. They have this bursty machine speed data flows that are controlled by real-time environmental triggers in some cases. Even though they use APIs, they don't rely on those well-defined API flows. They communicate and collaborate amongst themselves to solve the complex long horizon problems. And the ways they communicate changes. It's a very quickly shifting landscape. Right now, we're seeing MCP and ACP for communicating and sharing context, but we can say that tomorrow some new protocols will not emerge on the scene, and we need to pivot very quickly. Also, while performing the tasks, agent, especially ones based on LLMs, can exhibit non-deterministic and even deceptive behavior, and that makes it very difficult to predict and reproduce failures, which makes it very complicated to troubleshoot. Also, agentic workflows can span across domains and across platforms, and that requires very complex cross-domain orchestrational capabilities. And on top of all that, Agentic AI present a shifting attack surface because they have this continuous data consumption, they exhibit learning behavior, they invoke external tools, they interact between systems, so you cannot use any sort of static policies to secure them. Next slide, please. Actually, no, sorry, previous slide, I haven't finished. I forgot. Yeah, so what are those capabilities that telcos can bring to help with all that? It's, first of all, their physical infrastructure ubiquity and their peering relationships with other telcos, right? They own the connectivity fabric. They have the multi-cloud presence. They have the 5G edge sites where they can address latency requirements. They can bridge together different domains. They can provide the necessary visibility into the network for intelligent agent decision and for efficient flows. They are developing capabilities around creating network slices that have their dedicated quality of service, latency, SLA characteristics, so they can open that up for the agentic ecosystem. Also, telcos are trusted providers of critical national infrastructure, and they have been for years. They possess that deep expertise in network security. They know how to address regulatory compliance and how to do policy enforcement and very complex policy enforcement across different layers. So they can help address concern about data privacy, governance. They can alleviate safety concerns across agent and data life cycles. And also telcos have a real-time knowledge of their own network topology, right? They know where the resources are, which resources are available, and they know when those resources go away for whatever reason. They know what performance they can provide in the now, so they can make those smart decisions for intelligent and dynamic workload placement. Now, next slide, please. Great. Well, I don't want to leave an impression that all is, paradise in telco land, because there are definitely some gaps that service providers need to address before we can get this thriving environment for enterprise agents. That positive of the diverse infrastructures that I highlighted on previous slide is definitely counterbalanced by a lot of legacy systems that are still present in telco networks, and that includes vendor-specific hardware and especially siloed data that cannot be really unified for real-time use. This all can stall AI initiatives and inhibit scaling of AI agents. Another problem that we see is that AI skills within service providers are quite patchy. They're often siloed within technical teams as a result of the R&D experiments that they've done, and also small islands of internal AI adoption, and that basically fractures the landscape of their AI capabilities and the tools they're using. So it's very difficult to create that comprehensive adaptive environment that can be exposed to their customers. And very few telcos have that mature strategy on how they're going to educate and increase adoption across the broader workforce. Related to that is the fact that telcos are subject to very high organizational inertia. It's a consequence of a very understandable risk aversion of something that serves as an essential utility. So there is this tendency to stick with established processes. If it's not broken, let's not fix it type of mindset and culture. And that can result in friction when adapting these new AI-driven ways of working. And next one is the networks within brownfield providers, which is really vast majority of service providers. They span multiple complex domains that have different owners. So we have transport network, access, core, cloud, etc. And those are all effectively operational silos in many cases. So that lack of coordination between them may hinder the sophisticated, seamless end-to-end agentic flows that you want. And another blocking factor, which has previously affected successful rollouts of enterprise services, is the telco's ability to build true business ecosystems. For them to go beyond using AI just for the internal islands of efficiencies, for them to be able to unlock the revenues, they need to be able to safely, securely, in a trusted manner, expose their capabilities. They have even ability to do training, inference, to have network awareness. They need to foster a community of developers and partners to build the new intelligent services. And in many cases, we see the reluctance because they just don't trust that they have the capability of isolating their network from problems that might arise if you expose all those capabilities. So next slide, please. How can telcos go beyond being just connectivity providers to a platform of choice for enterprise agentic AI? Well, they need to become their own customer zero, really. They need to adapt agentic AI workflows and deploy agents across their own network. And that would allow them to build internal expertise, fill in the gaps, including the security gaps and the trust gaps that they might have within the network. And they can create a portfolio of capabilities that they can monetize and expose and productize for their own customers within enterprise space to consume, to create their own services. Next slide, please. We hope that Red Hat can be one of the crucial partners that can help service providers in their journey to becoming the platform of choice for agentic AI. We provide open source comprehensive modular AI platform, which gives them the freedom between the build it yourself and buy it, because we give you freedom to choose where you can deploy and what you can deploy, what type of hardware you can use, what tools you can adapt for what type of use cases that you see relevant for your services. With our OpenShift and OpenShift AI, we provide a layer of consistency across different types of environments, edge, public cloud, private cloud, all of those. And then we allow you to integrate your own tools or use the tools that we've already integrated into our platform. So we're not locking you into our choices. You can make your own choices that fit your needs the best. And that allows you to build a MLOps suite of capabilities that work for you, that allow you to do everything from training, fine-tuning, deployment, utilizing deployment pipelines, developing agents using frameworks. Llama Stack is what we chose, but you can pick your own framework. We also provide you a runtime environment for inference with Red Hat AI Inference Server that gives you a lot of optimization and flexibility of where you can place inference. So we strive to address all the concerns that I just talked about, including trust, safety, security, lifecycle management, both for the platform and for the agents as well. And all of that, basically we help you to put together the AI infrastructure that will scale be reliable, and enable the creation of value-generating services for your enterprise customers. Thank you.
Cool. Thank you very much, Rima. That was really interesting. And Rima will be staying on to join us for our panel discussion, for which, as Tilly mentioned, we've got a cracking lineup for. So just a quick reminder to those tuning in, if you do have any questions for our panelists, can see we've already started to have a few come through, but please do pop them in the chat and we'll try to address as many as we can live, and whatever we don't address, we'll follow up with separately after with a bit of a Q&A document. So as Tilly mentioned, we're joined by Andy Lynham, Principal Strategy Manager at Vodafone, and Miguel Angel Alvarez Bernardo, Chief Data and AI Officer at Orange. Andy, I'll come to you first. Rima and I both spoke about orchestration and how it underpins agentic systems, but I'd love to get a sense from your side of what Vodafone is already doing in this space. Are there any particular agentic AI initiatives, either internally or with enterprise customers, that are already being explored or trialed? It'd be great to understand sort of where you see the early traction or biggest opportunities emerging. And I guess just to add a bit more into that question, another layer, we had a question from a member of our audience onto, which I think is related to this, which is whether you have any suggestions on the best way to move beyond these trials or proofs of concept. So yeah, it would be great to get your thoughts on any of that.
Yeah, I'll just pick one and go from there. You know, there's so much work going on, and sometimes it's difficult to keep track of everything that's happening. We have lists of only children to apply this type of stuff internally. The stuff we've got, I guess, that's most important to us being a telco primarily is optimizing the network and making sure that the money that we spend delivers real value, which is real kind of return on capital for us. So there are agents that we've got that look at things like our CapEx. So where we're spending money expanding capacity in a certain area, could we actually use that to expand capacity to 2 areas? If we move the node, we put the POP in a certain different location. That type of stuff is really important and can save literally hundreds of millions of euros for us. Customer facing stuff, we've got some work going on with some of our partners to look at building a marketplace for AI agents. So there's a lot of individual use cases, a lot of individual kind of point solutions that you can say, this agent helps me to do this task. So your travel booking one that you mentioned, right? The real power of agents is when you got to get them to work together. So your travel booking agent might be able to go and query different websites. It might be able to go and query different risk registers. It might work out your visa requirements. It might be able to go and figure out from certain governments what the tax implications might be if you buy something and bring it back in. Getting them to work together, that's the real key for us. And that's where I think you're going to see a lot of the developments coming. There's a really good set of systems called Agency that's been originally written by Cisco, has now been made available to the Linux Foundation. And that's a great way of kind of looking at the entire agent system and saying, all right, so I need my agent to identify itself, to authenticate itself. I need to understand how I find other agents, how I interact with other agents, all that type of stuff. They're trying to put a framework around it. I think it's going to be really powerful, but it's going to need industry buy-in. And that's kind of the sort of stuff that we're working on right now. The focus is probably on the internal stuff, because that's where we can, to Rima's point, be our own customer and say, this is exactly what we've done. This is how we built it. This is what we've learned. And then we can start putting it in front of customers.
Brilliant, cool, appreciate that. And Miguel, turning to you, I'd like to hear what's happening at Orange. I'm aware so every operator is taking a slightly different approach when it comes to AI and automation. So it'd be interesting to understand how you're framing agentic AI within your broader strategy, and the type of use cases or capabilities that you're prioritizing and how they fit into Orange's overall roadmap.
So yeah, happy to do that. And honestly, first of all, I can say that we share some of the same concerns and focus areas with Andy and some of our peers in Vodafone and the other telcos. Since I come from Orange Business, one of the particularities of how we approach an AI is that we have internal needs that look a lot like the needs of our customers. So we are trying to bring those two together and build solutions that we can use both internally for our own transformation, a little bit like what you were saying earlier in the presentation as customer zero, but also that we can deploy and that we can make available for customers. And the two areas where we're seeing a lot of traction, and I'll comment as to why I believe that is customer interaction. How can we make interaction smoother? Everyone is used to chatbots that are not sufficiently intelligent, and now we can get finally to chatbots that can really do what you need them to do. And secondly, how we automate repetitive tasks internally, operational efficiency. And I can tell several use cases where we already have agentic AI going on. from preparing quotations and analyzing complex pricing processes to reviewing contracts to find specific clauses or documentation to supporting some of our troubleshooting processes. And today, these are not 100% autonomous systems. They are systems that support employees. We have always human in the loop. And clearly, the step that we want to go to is to see how you start increasing the level of autonomy, the level of adoption, and then new use cases become possible. And in fact, and I saw that there was this question about how you move from POC to industrialization. And my feeling is that the first thing is that we need to do more POCs at a lower cost. So I think you need to lower your cost of testing new use cases, and you need to lower the cost of the tests themselves. So you can then be very demanding in terms of saying, okay, is there real user customer adoption in terms of scaling this, and then you industrialize on the one that emerged at the tip of the iceberg as the one that have the highest potential. Because today, scaling and industrializing a use case, we're speaking about orchestration of systems, we're speaking about security, we're speaking about trust. It requires a certain investment, and the gap between a technology demo and a fully functioning industrial use case is probably wider than with other technologies. So I think it's good to having a wide array of use cases coming on and making sure that we focus our investment of those use cases that stand out, and then we industrialize because everyone is very clear on the ROI.
Perfect. They were two very good responses to what was a multifaceted, loaded question for myself. So appreciate that. And Andy, coming back to you, Miguel sort of referenced to it a little bit there, and it was obviously the focal point of my presentation. And remember, we've been talking a lot about this idea of orchestration being a foundational enabler for agentic AI. From Vodafone's perspective, what role do you see you guys playing in managing and orchestrating these complex multi-agent systems?
Yeah, it's a good question. I mean, if you look at a lot of the forecasts, what's going to happen to the network, the kind of short-term impact is minimal. You've got a small kind of single-digit % rise in the amount of traffic we're going to be carrying. So from a capacity perspective, I don't think there's much that we need to worry about. I think the key thing for us is how we enable the agents to kind of discover themselves and to authenticate themselves. So do we look at building specific agent gateways that sit in our network? So Model Context Protocol, MCP, has been quite a successful launch from Anthropic, and you can look at that and say, right, if I put an MCP server inside my network and allow all my customers to publish their agents effectively or their content through my MCP server, I can make life much easier for my customers, for their developers, for their teams to access this type of information. I think, to be honest, the pace of change is so fast right now that the areas we could invest in, the things we could develop, the locations we could decide are most important could change in a month, they could change in a week, they could change in a day. So at the moment, I think Miguel's point around being able to test faster, to prove things quickly, to do it at a low kind of cost-effective way is by far and away the best area you can look to invest in, because that gives you the flexibility to adapt, which is what you need now more than you've ever done before, frankly.
Cool. And Miguel, any reflections on that?
I mean, orchestration clearly has, again, it's a multifaceted question, not necessarily as loaded as you were saying, Jack, but it is a multi-dimensional topic. I think that short term, the question of trust and security are going to be the biggest gateways and the biggest blocking points to industrializing and scaling use cases. I think that telcos have a strong role to play there, both in terms of digital residency and sovereignty, as well as taking accountability for systems performing like they should. So I think that there is a good case to be made that is an area where telcos, us collectively, but also with our customers, we should prioritize investment, making sure that you can go from running use cases where both the data and the outcomes are non-critical to running progressively sensitive, but also potentially high-value use cases on agentic systems. Is going to be a tricky path. And I think that we can provide additional safeguards in terms of what information is accessed, how it is used, what are the rights given to a specific agent, and the scope in which it can evolve. There are a number of elements in there that can be pretty tricky, and I think we have a major role to play there. I do agree with Andy. I think traffic-wise, we're going to see impacts from agents down the road. Speaking with my colleagues in the network team, the anticipation that we have is that we're going to multiply the number of connection endpoints. So the number of sessions that you need to manage will increase maybe 100, 1,000 fold. And at that point in time, you may have this rush of connections and this storm of connections that kind of saturate the system. So we will need to anticipate for that. But I think that is still down the road. Today, the biggest drivers of network traffic when we look at Gen AI is moving the data. It's moving the data for training, it's moving the data for fine-tuning, it's moving the data closer to where the compute is, or moving the compute closer to where the data is. Those are the two drivers that are changing a lot of the infrastructure that both our customers are requesting and that we ourselves are deploying.
Sure. And sticking with that idea of where the compute is located and bringing it closer to the user, Rimmer, I know I've sort of kept you in the dark. We've not heard from you yet in the panel, focusing more on hearing our operator's voice, the two guys that are supporting us. From your perspective, how important is telco-owned compute infrastructure, especially distributed edge, in supporting and scaling agentic AI?
It's going to be crucial, especially as we move forward and we find new use cases for agentic AI that are related to devices, industrial, but also consumer devices, smart cities, all of those. You want to be as close to them as possible, and having that real estate is crucial. To provide the minimum latency and to ensure that latency, it's going to enable a lot of use cases that are not possible if you only have centralized compute resources. We also anticipate that you're going to have a lot of sort of federated learning happening at the edge, due to all the concerns of sovereignty, right, security and trust. So being able to process the data right where it's generated, essentially, without having to send it anywhere, that also requires that edge compute capabilities. And you're seeing a lot of planning already going around it of, how can we utilize our RAN footprint to enable all sorts of cool AI things. So I do definitely think it's one of telco's winning propositions, that they have that type of compute near where you're really going to want it.
Perfect. And Andy, anything you'd add to that?
Yeah, I would. I think there are geographic nuances around different parts of the world that are going to have a big impact, because Rimmer mentioned sovereignty, and that's probably behind AI the single most important topic for a lot of our customers. But if you look at the actual size of a typical European country, particularly the smaller ones in Eastern Europe, to achieve low latency, high performance stuff, you can typically put a node in the middle of the country and you've got, sub 10 millisecond latency. Whereas if I look at somewhere like Germany or France, I might need 3 or 4. If I go to North America and China, I might need 50. So there's a real kind of geographical implication in terms of, yes, you might have compute locally, but do we need that compute locally? Can I put a single node in the middle of a small country and say, yeah, if I take the UK, if I put a single node in Birmingham, right in the middle, I can probably get sub 10 millisecond latency from Cornwall and from Scotland all the way down. So we need to think quite carefully about how we prioritize these investments, because if I was working at a big American telco, I'd be all over my stuff going, right, I need to make sure I've got all these key cities covered with local nodes, and metro networks become really, really important. It's a very different story in Europe, where you've got nodes scattered all over the place, but we might not need to look at operationalizing as many of them as we would if we were operating in the biggest of countries.
Fantastic. And that was a very comprehensive deep dive into sovereignty. But Miguel, anything you'd add?
Yeah, I tend to add with Andy. For me, local compute is becoming increasingly important at 2 levels. As I was saying a moment ago, one is sovereignty, the other one is performance. I think that for performance, we really need to get in industrial closed-loop systems where you have agents interacting with the factory floor, where you really need that sub-millisecond or sub-10 millisecond latency on a reliable basis. And there is both the geographical aspect that Andy was mentioning, but I think there is also the local survivability aspects. When you want to make agents part of your workflow, part of your industrial production workflow, you may want to make sure that those agents are as reliable as the machines that they're interacting with. So at that point, you're going to want to have that local compute. But it's always going to be a trade-off between that proximity, that reliability, and the efficiency and scale that you can get from more centralized locations. So I think that we're going to see first a push for having sensitive workloads in in country, and it can be in the middle of the country, as we were saying a moment ago. And as you move towards maybe robotics use cases, more advanced use cases, more advanced command and control use cases, you may have more performance demands. Today, if I'm perfectly transparent, I do not see that that's where the bulk of the demand is coming from. There may be some research going on about what we can do tomorrow, but we need the technology and the controls that we can bring to that technology to come up and to mature in order to make these use cases feasible.
Cool. And Rima, conscious maybe there may be some slight bias here, but where do you see the most promising opportunities for partnerships to deliver agentic AI orchestration at scale?
As I think we've already touched on working with industries, because I think they are exhibiting the behavior where agentic AI would be most beneficial, and convincing industries that telcos are the best partners for what they're trying to achieve. It's not an easy task, by the way, but if we're able to do that, I think the benefit for both the industries and the telcos would be tremendous, in my personal opinion.
Cool. And Andy, anything that you would comment on there?
Yeah, I think from a partnership perspective, the most important thing for me is adherence to standards, and that's a problem right now because we don't actually have the standards. But as soon as we kind of have them sorted out, we have them nailed down, things like A2A and MCP become written in law, effectively saying this is how an agent discovers protocols, this is how an agent talks to another agent. Once that's nailed down, it needs to be front and center in terms of any discussions we have with our partners, because we don't have to build things multiple times. We want to build one gateway once that then uses A2A to discover whatever other agents it needs to go and talk to, as an example. So making sure that we are working as closely as we can with the standards bodies, with the companies that are leading this type of work, like Anthropic, is really important to me. I mean, obviously you've got size, scale. Do I have my own large language models? Can I train them? Can I fine tune them for your use cases? That type of stuff, which is really important. But for me, the overriding concern is standards and simplifying how we can interact with the partners we've got.
Cool. And is standards at such a point in priority for you at Orange, Miguel?
I wouldn't maybe name it standards, but the feeling is essentially the same as Andy. We are looking for open collaboration, and we're looking for customer choice. We were speaking earlier, for instance, about sovereignty, and we don't want customers to feel that either they do everything on-prem and they will do everything themselves, or they do everything on the cloud and then they are tied to a single provider and then they have no choice for sovereignty. We want them to have this choice and to be able to interact with different technology providers for different use cases and different needs. So clearly, as Andy was saying, I think it's very important to have an open platform approach. I think that A2A and MCP are both fantastic news, and I'm really positive about the way that the industry is embracing this interconnection. I think that the ecosystem is moving so quickly that everyone understands that you are not going to have the latest technology on every single category, so you need to be able to play nice with the rest of the ecosystems. And I think that telcos are a neutral third party. We are not an LLM developer. We're not a direct competition to many of these technology vendors. So we are able to work together with technology partners, both on building the platform, and Rima was mentioning some of the components that can be used in that direction, but also with the providers of bleeding edge technology, either on compute or on LLMs or on some of the applications. And for me, the key priority in that space is to preserve customer choice, to make sure that they can build the solution that they need depending on the use that they want to have.
Perfect. And finally, I'm conscious we've only got about 5 minutes left, so I'll ask if all of our panelists can keep their responses to roughly 1 minute each. An interesting question that I've cherry-picked from the number of questions we've received from our audience. They said, in mission-critical applications where a wrong command could bring down an entire network, do you think agentic AI systems should operate under a hierarchical right structure with limited, high, and full access agents where they always keep a human in the loop for approval of critical actions? Rima, I'll come to you first. What's your thought on that?
I was good with it up until always having a human in the loop, because that would sort of defeat the purpose.
Very true.
We do want to operate, if you will, within zero trust framework. Give only permissions to agents that they absolutely need. Figuring that out is going to be a fun challenge. But if you always put human in the loop, then what is the purpose of having these autonomous agents?
Agreed. No, and Andy, I assume are your thoughts similar?
No, we just let the agents run wild and do what they want. It's fine. No, so we go into it before. It's about evolution. It's about testing them, trying them, proving them. And once they can prove themselves, it's the same way with you train a human employee, right? If we have a new engineer who we recruit and we say, right, these are where the systems are, these are your command interfaces, 20 years ago, this is how it operates. They spend some time working with it and they get to understand it, and then you let them have access to the network. It's exactly the same. These new fantastic acronyms like HITL for human in the loop, you've got HOTL for human on the loop, where you've got a level of supervision, and you've got HOOTL, human out of the loop, where you let the agent run loose. It's all about proving themselves in exactly the same way that humans have to do, for me.
Cool. And Miguel, you've got an extra minute. Anything that you would add or disagree with?
I would say +1 to what Rima. Yeah, I would say +1 to what Rima and what Andy said. I will get just one nuance, which is to say that even when agents have proved themselves and you have complex evaluation mechanisms to make sure that the results are what you expect, in the same way that we do it with humans, for particularly risky procedures, we'll have a special validation process, where there is maybe a second human check-in, that is maybe a superior or a managerial approval, something like that. I think that LLM as judge and supervision mechanisms for LLMs and for agents are going to become more and more widespread. So I would expect many tasks to be fully delegated to agents as we go forward, but I wouldn't expect ever to have an agent with full rights that can do everything all the time. I think that we will always have a control mechanism, particularly when that agent has rights to tasks and to actions that could be damaging if they are misused. So I think that those two need to escalate together. And what I would expect is that the more sensitive agents becomes, the more sophisticated the threats will become. So the more sophisticated the protection that we need for those kinds of infrastructure. At the same that we would do, by the way, for our core network or our core infrastructure. Anyway, it's not different just because it's AI.
Perfect timing as well. So that is pretty much all we've got time for today. Thank you to our audience for asking some of those insightful questions. We will be sharing a follow-up Q&A document answering all of these questions along with the slides, all the questions that didn't get answered, as well as sharing the slides and the recording from today's session. Thank you so much to Rima for presenting and then also being on our panel, and to both our panelists, Andy and Miguel. Really appreciate everyone tuning in, and we'll see you next time.
Thank you.
Thank you.
Thank you very much. Bye.